Saxon Advanced Math 10C is completing the square. And I want to just point a couple of things out here before we get into the actual lesson of completing the square. And that is, if I have a squared term equals a number, I know if I take the root of both sides, I have a positive or a negative value. And that's important to realize that it could be either one, right? It could be a -3 times -3 is positive 9, and 3 times 3 is positive 9. So I could have two possible answers. Well, what if I had something like this? X plus 2 squared equals 4. Well, if I took the root of both sides, I would say x plus 2 is plus or minus 2. And then if I took 2 away from both sides, I'd say x equals -2 plus 2 and -2 minus 2, so -4 and 0. And these would be great if that's all we had to do, right? And we could solve this out. One of the things that we need to point out before we get into actually factoring using completing the square is understand what a perfect square is. A perfect square is when half the middle term squared equals the last term. What's half of -6? Well, that's -3. Square it, you get 9, and that works. So if I were to do the old-fashioned method, or the way you may have learned how to factor originally, you say I take two parentheses and I put an x in the beginning of each because there's a coefficient of 1 here, so I know that they're both going to be x. And then I look at the factors of 9, and the factors of 9 are 9 and 1 and 3 and 3. And I say, well, what are those factors being multiplied together to equal 9? Well, both do. Any of those variables do? Well, how could I get them to add to 6? Well, 1 and 9 can't add to 6, but 3 and 3 do. So I realize it's a 3 and a 3, and they're going to add to -6, and that works. And you may have recognized that this would be the same, and I could write this as x minus 3 squared. Well, if that was x minus 3 squared equals 0, I would know that the two variables are 3 and 3. Just like I did this one here, knowing that if I took the root of both sides, I could work that out. Well, the important thing to realize is every time you use a perfect square, half the middle term is the third term. We're going to take a very simple one here. The book jumped into a little more difficult problem. But if I said x squared minus 4x minus 12 equals 0 and asked you to factor it, you may set it up with the two sets of parentheses like this and say what when added together is -4 and when multiplied is -12. And it wouldn't take you very long to figure out that that would have to be 6 and 2 or the factors of 12 that would work with a -6 and a +2. And there would be my factors. Well, let's work a very simple problem like this using completing the square. And it does always work. It works the same way. It gives you an answer every time, even when you're saying, I don't know what numbers would multiply to the one and add to the other. So what I did here is I just broke this up and I said, let's put the 12 on the right-hand side. So we did. We added 12 to both sides. Then I say x squared minus 4x equals 12. That's fine. And I realize this is not a perfect square, right? If I take half of -4, I get -2, and square that, I end up with a +4. That's not what 12 is. But what if I had a way to do that? So that's what we're going to do. We separated these out, and we left a spot here. Well, what if this was a perfect square? If I could pick the problem instead of using the problem that's given to me, I would say half the middle term squared would be the perfect square. That way I could just take the square root of both sides and have an answer. So that's what we do. We say, well, what's half of -4? Well, -2. We'll square that. That's 4. And I put a 4 here. And I'm allowed to do that as long as I do what? And if you remember, the balancing equations means that as long as I do it to both sides, I'm allowed to do so. So I add a 4 to this side too. Notice I added a 4 on both sides. Well, that makes it easy, right? Now I know the factors of this without having to even break it up. I already know that half this term equals that one. So it's x minus 2 and x minus 2 without having to think through all those individual steps of doing so. And I say 12 plus 4 is 16. And so I have that set and I'm ready to go. Now, at this point, I would say x minus 2 squared equals 16. I just said, well, x minus 2 times x minus 2 is x minus 2. Now, if I took the root of both sides, I'd end up with the root of 16, which is plus or minus 4. Now notice I had to put the plus or minus in there because 16 has two sets of roots. And then I say the root of x minus 2 squared is x minus 2. And I don't have to use a positive and minus in the front of this. It would be redundant because it would be the same as doing this, that over here. So if I did do that on both sides, and I've seen students do that before, they put it on both sides, they end up with 4 answers, but only 2 of them there are unique. And that's okay. That didn't make sense to you, but you don't need it on that one if you're doing it on this side. So at this point, I realize I need to get rid of this negative 2, and I add 2 to both sides, and I end up with 2 plus or minus 4. Well, 2 plus 4 is 6, and 2 minus negative 2 is going to be negative 2. So, or 2 minus 4 is negative 2. So I end up with 6 and negative 2. Now notice that these would fit in here to equal 0, which means I could put them back in and say, oh look, obviously these are opposites because this is equaling 0, right? And if it were to be equal 0, this term has to be 0 or this term has to be 0. So my answer for x, so I'm factoring this out using completing the square to factor it, is the same as if I didn't use this method. I used the method I had before. However, it's actually giving me what x is. See, if I were to say this is equal to 0 here, I would have said x minus 6 equals 0, so I add 6 and I get x equals 6. And I would have said x plus 2 equals 0 and subtract 2 and get x equals negative 2. Those are the answers that I have. So I know that this does work like it should. Now let's get a little more exciting here. Let's do one that I couldn't do in my head. Example 10.6 is one that fixed that bill. There's no way I'm going to do this in my head. I don't know what to do with this, so the very first thing I'm going to do is put it in the correct format. 3x squared minus x plus 5. So I just moved it around. In order for completing the square to work, I need to get rid of this 3. So I divide everything by 3. Well, 0 divided by 3 is 0. Very easy, it's 0. 5 divided by 3. I made this a 1/3, and you'll see why in just a minute, instead of just putting this over 3. And that cancels that 3, makes this a 1. At this point, I'm ready to complete the square. Well, half of negative 1/3 is 1/6, and 1/6 squared, or negative 1/6 squared, is 1/36. That's not 5/3. It's not a perfect square. So I move the 5/3 to the right-hand side. Now, I need to half this term and square it. Well, half of negative 1/3 is 1/6. Negative 1/6. Negative 1/6 squared, 1/36. So I put that here. I add the 1/36 to this side. I have to do this step to make this equation true. Now that I know that that's true, I start looking for common denominators, which I did by 36. Add that and get a negative 59. On this one here, I look at it and say, well, half of this squared, right, is this term, so it's a perfect square, so I know it's negative 1/6, because that's half of negative 1/3. Multiply it by 1/2. 2 times 3 is 6. Now I look at this and say x minus 1/6 squared. I know what to do with this now. So I combine my like terms and I end up with this here. And I take the root of both sides. Well, the root of a square gets rid of it, but that doesn't work on this side. And this one is going to pull a little deeper for you. The root of negative 59. Well, the negative 59 becomes root of negative 59i. Remember, root of negative 1 is just I. And the root of 36 is 6. So now I did slip in that plus or minus because it can be either one. Then I move the negative 1/6 to the right-hand side, and I get 1/6 plus or minus the root of 59 over I over 6. This is technically correct, although if I want to think of it this way, I really have two answers in here. I have 1/6 plus the root of 59I over 6, and 1/6 minus. There's my plus and minus being thrown in correctly. So these are my two answers. These are factored out and solved using completing the square. Just like I could do with real numbers, this one ends up working out imaginary because of a negative root. But there's no way that I could have looked at this and said, can I factor this and find out the values of x by just guessing? I would have never guessed that it's the root of negative 59 over 6. There's no way that I could have come up with these. But by completing the square and making it into something I recognize, a perfect square trinomial, I'm able to do this by this same method. And this works every time. There's a couple of things I want to point out. In order for it to work, the coefficient has to be 1. So if there's a number out here, divide that out of everything. The other thing is, get your other variable that or your other constant that you have on here, which is on this one was 5/3, on this one was the negative 12. Move that to the right hand side and get rid of it, and then go ahead and do you're completing the square. So there is other methods that you can use with completing the square. It's called same side completing the square. We'll get into that later on in the book. For right now, move it to the right hand side of the equal sign like we did here. Half the middle term, square it is the third term, but if I add it to one side, I have to add it to the other. You can follow this through. Very, very simple to do. You won't struggle with this as long as you remember a couple of these rules. This is a method that we memorize that says if I can only make it look like something I know how to work with it. And we know how to work with perfect squares, so we make everything that we come into a perfect square. and therefore we're able to factor it out.